5 days ago, the ground off the coast of southern Mexico ruptured with the force of over 11 megatons of energy. 6 million people felt it. A tsunami warning went out across 3 countries. And it still hasn't stopped. On July 17, 2026, a magnitude 7.3 to 7.4 earthquake struck off the coast of Chiapas, Mexico, near the Guatemala border. It triggered tsunami warnings, shook buildings as far as El Salvador, and set off an aftershock sequence that authorities are still tracking today. The tsunami threat was lifted within hours. No major damage was reported. On the surface, this looks like a story that's already over. It isn't. And by the end of this video, you're going to understand exactly why scientists are still watching this exact stretch of coastline, and what it tells us about one of the most seismically active regions on Earth. Let's start with the moment itself. At 8:48 in the morning local time, USGS recorded the earthquake's epicenter roughly 48 kilometers southwest of the town of Aquiles Cerdán, near the port of Puerto Madero, at a shallow depth of about 15 kilometers. Shallow earthquakes matter because they transmit shaking to the surface far more efficiently than deep ones, which is exactly why this quake was felt so strongly, so far away. USGS estimates that 6 million people across Mexico, Guatemala, and El Salvador experienced moderate to strong shaking. In Guatemala City, Reuters witnesses described residents rushing out of their homes into the street. Government building staff evacuated under emergency security protocol. The tremor was felt in El Salvador too, buildings shaking in a country that wasn't anywhere near the epicenter. Here's a detail almost nobody reported. This earthquake didn't come out of nowhere. 2 foreshocks quietly preceded the main event, including a magnitude 4.7 tremor, just 88 minutes before the big one hit. In hindsight, that 88-minute warning sign is exactly the kind of pattern seismologists study after the fact, trying to understand whether foreshocks like that can ever reliably predict what's coming. And so far, the honest scientific answer is that they can't, not with any useful precision. You cannot tell, in the moment, whether a small quake is a warning or just background noise. Mexico's Naval Tsunami Warning Center initially issued a warning for hazardous waves up to 1 meter above tide level across a 300-kilometer stretch of coastline. Hours later, after analyzing real sea level data near the epicenter, they canceled it, confirming no significant wave activity had actually developed. That's the version of this story most headlines carried. But it's not where this earthquake actually ends. Consider what those first few hours actually looked like on the ground. Mexican President Claudia Sheinbaum said preliminary reports from Chiapas and Tabasco showed no structural damage in the immediate aftermath, a statement that, in the moment, would have been genuinely reassuring to millions of people who had just felt their homes shake violently. Guatemala's President Bernardo Arévalo separately confirmed no fatalities had been reported in his country. 2 heads of state, in 2 different nations, both publicly addressing the same earthquake within hours of it happening. That alone tells you how seriously this event was treated at the highest levels of government, even before anyone knew the full scale of what had happened. Because within hours of the main shock, something started happening that most people never heard about, and it still hasn't fully stopped. By midday on July 17th, authorities had already recorded roughly 80 aftershocks. The largest one measured magnitude 6.5. Powerful enough on its own to be a significant earthquake anywhere else in the world. USGS separately logged at least 10 aftershocks, ranging from magnitude 4.9 to 6.0. rattling the region throughout that same day. 2 people were injured in the city of Tapachula, one after jumping from a third-floor window during the shaking, the other hurt by a falling door. Minor damage was reported across Chiapas, including structural cracks in buildings, not catastrophic. But not nothing either. Here's the number that puts this in perspective. USGS data shows that over 2 million people live within just 200 kilometers of the epicenter. Soil liquefaction warnings. Remember, that's when shaking causes water-saturated ground to temporarily behave like liquid, were issued for more than 110,000 residents in the area. That's not a statistic from a hypothetical worst-case scenario. That's an active warning issued to real people, in real neighborhoods, in the days immediately following this quake. And this wasn't a one-day event. Reports from the region describe aftershocks continuing for days after the main shock. A pattern seismologists say is completely normal after an earthquake this size, but one that keeps residents on edge every single time the ground moves again, never quite sure if it's another aftershock or the start of something bigger. Put yourself in the position of someone living in Tapachula, or one of the smaller coastal towns near the epicenter right now. You've felt the main earthquake. You've felt dozens of aftershocks since. Officials have told you the tsunami threat is over, but they've also told you your ground could liquefy if another strong quake hits. Every time your house creaks, every time a truck rumbles past outside, there's a moment of genuine uncertainty about whether that's just daily life or the start of the next event. That psychological weight, the accumulated uncertainty of an aftershock sequence that won't fully resolve, is part of the disaster that never makes it into a magnitude number or a casualty count. So why did this happen here specifically? To understand that, we need to look at what's actually happening underneath southern Mexico. Because this isn't one fault line. It's 3. Because Chiapas doesn't just sit on one dangerous fault. It sits at the exact point where 3 separate tectonic plates meet. The region around Puerto Madero sits at the intersection of the Caribbean Plate, the North American Plate, and the Cocos Plate. 3 massive pieces of Earth's crust grinding against each other in the same relatively small stretch of coastline. The Cocos Plate is the one doing most of the work here. It's being forced underneath the North American and Caribbean plates in a process called subduction, moving at a rate of roughly 6.4 centimeters per year. That might sound slow. It's about the speed your fingernails grow. But over decades and centuries, that constant grinding motion builds up enormous stress. Stress that eventually has to release, usually all at once, in the form of an earthquake. There's actually some scientific disagreement about exactly what kind of fault ruptured on July 17th. Some analyses point to this being a more typical subduction event along the main Cocos North American boundary. Others, looking closely at the data, note that no tsunami warning would normally be expected from a shallow subduction quake of this size, and argue the rupture may have actually occurred along a different structure entirely. The Polochic-Motagua fault system, a major strike-slip boundary where the Caribbean and North American plates grind horizontally past each other, rather than one plate sliding underneath the other. That kind of fault typically produces less vertical seafloor displacement, which would explain why the tsunami threat turned out to be minimal despite the quake's strength. Either way, the conclusion is the same. This is one of the most geologically stressed, most complicated fault intersections on the entire planet. And the historical track record proves it. This exact region, Oaxaca, Chiapas, Tabasco, was the site of Mexico's strongest earthquake on record, a magnitude 8.2 event on September 8, 2017 that killed 98 people and triggered a real, damaging tsunami. According to long-term seismic data, earthquakes of magnitude 8 or higher strike Mexico roughly once every 25 years on average. For quakes of magnitude 7 or higher, the category this new earthquake falls into, that average interval drops to roughly every 3 years. So this isn't a freak isolated event. It's the expected, statistically regular behavior of one of the most active fault systems on the planet, doing again roughly what it's done every few years for as long as records go back. It's worth understanding just how different this new earthquake was from that 2017 disaster, because the contrast tells you something important. The 2017 quake struck at night, at a greater depth, and generated a genuine tsunami that contributed to the death toll. This year's earthquake struck in daylight, during morning hours when people were awake and alert, at a shallower but structurally different fault type that ultimately didn't produce a damaging tsunami. Same broader region, same tectonic forces, but different specific conditions producing a dramatically different human outcome. 98 deaths in one case, 0 confirmed fatalities in the other, despite both events registering in the same magnitude range. That's not luck. That's a reminder that an earthquake's magnitude alone doesn't determine how deadly it becomes. Timing, depth, fault type, and building preparedness all matter just as much. But this fault system isn't operating in isolation. It's part of something much bigger, a ring of tectonic activity that circles almost the entire Pacific Ocean. Chiapas sits directly on the Pacific Ring of Fire, a roughly 40,000-kilometer horseshoe-shaped zone of tectonic boundaries that circles the Pacific Basin. This single geological feature is responsible for approximately 90% of all earthquakes on Earth and around 75% of the planet's active volcanoes. That statistic is worth sitting with for a second. 90% of every earthquake that happens anywhere on this planet happens somewhere along this one ring. Mexico, Guatemala, Japan, Indonesia, Chile, Peru, New Zealand, and parts of the western United States all sit on this same structure, which is exactly why all of these countries independently maintain sophisticated earthquake preparedness programs. They're not being cautious for no reason. They're sitting on the most seismically dangerous real estate on the planet. This also connects directly to something we've covered before on this channel: the ongoing seismic activity we've tracked in Venezuela and the fault systems along the California coast. Different countries, different specific fault lines, but the same underlying pattern. Regions positioned along active tectonic boundaries experiencing earthquake sequences that unfold over days and weeks, not just a single moment. Look at the map of the Ring of Fire for a second, and you start to see why this keeps happening in cycles across different parts of the world, often within the same general stretch of months. The Pacific Plate, the Cocos Plate, the Nazca Plate, the Philippine Sea Plate. All of these are constantly, independently building and releasing stress along their own boundaries. They're not mechanically connected in a way that means one earthquake causes another thousands of miles away. But they are all part of the same restless planet. And when you're tracking global seismic activity closely, as we do on this channel, you start to notice just how often multiple regions along this one ring are actively releasing stress within the same general window of time. The USGS's own hazard assessment for this event used something called the PAGER system, Prompt Assessment of Global Earthquakes for Response, which estimates likely casualties and economic losses within minutes of a quake, based on population density, building types, and shaking intensity. This event was rated at yellow alert level, meaning the system flagged a real possibility of localized casualties and moderate economic losses. Not a worst-case scenario, but not a non-event either. That's exactly the level of damage that ended up occurring. Injuries, structural cracks, no fatalities reported, but a genuine, monitored risk the entire time. So here's the honest scientific question underneath all of this. The one that actually matters more than any single earthquake's magnitude. Does an event like this make a bigger earthquake more or less likely in the near future? The answer scientists give isn't as reassuring as you'd hope, and it's worth understanding exactly what they actually mean when they say a region isn't done. Seismologists studying this event have been direct about one thing: a magnitude 6.0 aftershock, like the ones already recorded in this sequence, is nothing to dismiss on its own. And the region's underlying geology means that larger events remain possible in the weeks following a significant tremor like this one. Here's what that actually means in practice, not in headline language. After a major earthquake, the surrounding fault system doesn't simply go quiet. Stress that didn't fully release during the main rupture can transfer to nearby sections of the fault, sometimes increasing the pressure on segments that hadn't yet slipped. This is exactly the mechanism scientists point to when they explain why aftershock sequences can occasionally include an event nearly as large as, or even larger than, the original earthquake. Though statistically, that outcome remains the less likely one. Most aftershock sequences do taper off gradually, each event a little weaker than the last, fading out over days or weeks. The honest, complete picture is this: nobody, including USGS or Mexico's National Seismological Service, can tell you with certainty whether this specific sequence is finished or not. What they can tell you is what the data shows so far: a shallow, energetic rupture along a historically active fault intersection, followed by dozens of aftershocks consistent with normal post-earthquake behavior, in a region that produces major earthquakes on a fairly predictable multi-year cycle. This is actually one of the most honest admissions in all of earthquake science, and it's worth sitting with rather than glossing over. Despite decades of research, billions of dollars in monitoring infrastructure, and some of the most sophisticated seismic networks on the planet, scientists still cannot predict exactly when or where the next major earthquake will strike. What they can do, and what agencies like USGS actually excel at, is rapid detection, accurate hazard mapping, and probability-based risk assessment. That's a meaningfully different skill than prediction, and it's important not to confuse the two. Nobody issued a warning saying, a 7.3 will strike Chiapas on July 17th. What they can say, both before and after the fact, is that this region carries a persistently elevated risk, and that risk hasn't gone away just because the immediate news cycle has moved on. That's not a prediction of doom. It's also not a clean, all clear. It's exactly what it looks like when a genuinely active fault system does what active fault systems do: releases stress, keeps adjusting for days afterward, and gets watched closely by scientists who know this particular stretch of coastline has produced Mexico's strongest earthquake on record before, and could statistically do so again within the coming years, even if not from this specific sequence. So let's bring this together. On July 17, 2026, a magnitude 7.3 to 7.4 earthquake struck off the coast of Chiapas, Mexico, at the intersection of three tectonic plates, felt by an estimated 6 million people across 3 countries. It triggered a tsunami warning that was later canceled, produced roughly 80 aftershocks, including one at magnitude 6.5, and left over 110,000 residents under active soil liquefaction warnings. 2 people were injured. Structural cracks appeared across parts of Chiapas. And 5 days later, as of this video, seismologists are still watching the sequence because this exact region has a documented history of producing some of Mexico's most destructive earthquakes. This isn't a story with a clean ending, because the geology underneath southern Mexico doesn't offer one. The Cocos Plate is still subducting. The stress is still building. And history says another major earthquake here isn't a matter of if, but roughly when. On a timeline measured in years, not centuries. Let's do one final recap of the numbers together, because laid out back to back, they tell the real story better than any single headline did. A magnitude 7.3 to 7.4 rupture. 6 million people who felt it. 80 aftershocks in the first day alone. A magnitude 6.5 aftershock powerful enough to be a major earthquake on its own anywhere else in the world. Over 110,000 residents under liquefaction warnings. And a historical pattern showing earthquakes this size return to this exact stretch of coastline roughly once every 3 years. Individually, each of those numbers describes one moment in a 5-day-old story. Together, they explain exactly why this isn't a story that's actually over. It's one that scientists are still actively watching unfold. We're going to keep tracking this aftershock sequence, along with the broader pattern of seismic activity we've been covering across Venezuela, California, and now Mexico. Because these stories don't end when the headlines move on. They keep developing in the data long after most coverage stops paying attention. If this video helped you understand what's actually happening along this fault line, hit subscribe, because we'll be covering the next update the moment the data changes. And if you want to see how this same ring of fire connects to the fault system we broke down in our Cascadia megaquake video, go check that out next. Same tectonic story, different coastline, same reason scientists are watching both closely. Thanks for watching. We'll see you in the next one.